Howdy, PreCal. It is Miss Kosh. I am finishing up our sequence notes. So I did arithmetic sequences first, which have a common difference. And now I'm getting to geometric sequences. I like to put my name on my work. Okay, so here are some examples of geometric sequences. So hopefully you can figure out the next term. So I see 3 to 6 to 12 to 24, excuse me. I am multiplying by 2 each time, so then I get to 48, and then I get to 96. Okay, the next one, and this, in a geometric sequence, we are multiplying by the same thing each time, and we call that our common ratio, so we use the variable r, and so our r value was 2. So the next one, I see 160, 80, 40, 20. Oh, I'm taking half of the previous term each time. So if I multiply 10, I was about to say, when I wanted to say it was multiply 20 by 1/2, you get 10, but I went to, when you multiply 10, oh, I'm giving away my answer. Okay, and then half of 10 is 5. Okay, and then this next one, I'm going from positive to negative, positive, negative, positive, negative. So notice, if I multiply 2 times negative 5, I get negative 10. If I multiply that by another negative 5, I now have a positive 50, and then a negative 250, okay, and so forth. So this would be, I'm going to multiply by negative 5, so I'm now at a positive 1250. Multiply that by a negative 5, and it's negative 6250. How did I know these? Well, I know these because I know powers of 5. So 5 to the first is 5, 5 to the second is 25. I know 5 to, they're funny looking 5s. 5 to the third is 125, and 5 to the fourth is 625. And so they just had a 0 behind them. So hopefully I'm right. Okay, and on this one, my r value was equal to negative 5. So I can oscillate back and forth between positive and negative terms in a sequence like that. Okay, so let's look at this. We're going to try and figure out how we will write the rule. And so I came up with this sequence 2, 6, 18. Hopefully you noticed that we're multiplying by 3. Multiply that by 3, 30 plus another, oh man, 54? Is that right? Okay. So this is 2, and this would be 2 times 3. And this is 2 times, not 2, 3 times 3, and this is 2 times 3 times 3 times 3. Oh yeah, 27 times 2 is 54. I was right. Okay, if I multiply that by 3, 150, 162, and then this becomes 2 times 3 times 3 times 3 times another 3. Okay, and you may notice this is 2 times 3 to the first, and this is 2 times 3 to the second, and this is 2 times 3 to the third, and this is 2 times 3 to the fourth, and this is actually 2 times 3 to the 0 power. So anything to the 0 power is 1. And so notice the connection between these, this 1 and 0, and 2 and 1. Notice those numbers right there. If I take this number up top and subtract 1, I get the number that's in the exponent. Okay, and so now my general form is I started with, I had 2, and I multiplied it by 3 to the n minus 1 power. Okay, so there we go. That is our nth term of that particular problem. So let's see. If we want, I'm calling now, I default to calling all sequences A sub n, but it is kind of nice when you talk about a geometric sequence being G sub whatever. So this works in the similar way that our arithmetic did. Except now we are multiplying by the same thing as we move down the line here. So if I'm at the first term and I want the fifth term, I'm going to have to multiply by the common ratio 1, 2, 3, 4 times. So this becomes g sub 1 times r to the fourth power. I was trying to figure out how to type this up and make it where r to the fourth like that. Can you tell that that's what I'm trying to do? Pretend. Okay. So hopefully that makes sense. And then, so let's work through a few of these. If I want the 8th term and I'm at the first term, then I want the 8th term, I'm at the first term, I have to multiply 1, 2, 3, 4, 5, 6, 7 times to get there. So that's times r to the 7th power. If I want the 7th term here, but I'm at the 4th term here, I have to multiply 1, 2, 3 times. If I'm at the 3rd and I want to get to the 10th, the 3rd, oh, that's just getting messy. It's r to the 7th power. So hopefully you recognize it's 10 minus 7. And so if I'm at the first term and want the nth term, then I'll have to raise it to the n minus 1 power. if I'm at the k term, some random term where n is bigger than k, then we'll multiply this, we will raise this to the k, I lied. We will raise this to the n minus k term. And once again, what comes right before the g term, the n term? N minus 1. What comes right after it? N plus 1. Okay, so now we're writing the first 4 terms of the following sequences. So I've given you the sequences as both a recursive formula and an explicit formula. I can't spell. There we go. And so I have here, I'm starting, my first term is 6, and I'm multiplying it by 2. And then I multiply it by 2. And then I multiply it by 2. And there's the first 4 terms. Okay, so the next one, we do b sub 1 would be equal to 7 times 3 to the 1 minus 1. That's to the 0 power. And that's just going to equal 7. And so my second term is going to be 7 times 3 to the 2 minus 1, which we notice is now 7 times 3 is 21. What did I do to go from one to the next? I multiplied it by 3. So the next one would be 63. And then the next one, multiply that by 3, I get 189, I think. I could plug it in if I wanted to, but there we go. The next one here, we're starting at 64. What did I just delete? Oh, I deleted that. Sometimes I tap the screen and it deletes things that I don't intend. Okay, so we're starting at 64, and we're going to take half of the previous term. And so now we're at 32. Half of that is 16. Half of that is 8. And there are my first 4 terms. The next one, now notice this is slightly different. We see this form where it's raised to the n minus 1 more often than this, but they both are geometric sequences. They both work either way. So you got to pay attention and make sure I'm not trying to trick you, or try to be sneaky. Okay, so u sub 1 would be 96 times 3/4 to the first power. So the very first term, over here, our first term was this number, was 7. But that's not true here because we actually have to multiply it by 3/4. So what I might do is come in and say, what was it, 96 times, let's do 3/4. Come over and do a parentheses and raise this to the x power. And then I think there's a way I can make this a table, right? Yeah, there we go. Okay, and so I see my first term. Let's do, there we go, enter, enter, enter. I wanted the first 4 terms. So the first 4 terms, okay, you get to watch me do all the things. Done. Okay, and let's add that little picture. Okay, it's a big picture. Cancel. And so my first 4 terms are these. Term 1, term 2, term 3, term 4. So that was 72, and then the rest are up there. Cool. I prefer maybe a fraction. This would be like 81 over 2, but whatever. Okay, so now given 2 terms, find the nth term. And what I have g sub 4 would be equal to g sub 2 times r to the 4 minus 2. So g sub 4 equals g sub 2 r squared. So now let's plug in what we know. 324 equals 144 r squared. So when I divide 324 over 144, it's really going to be helpful. Come here, Desmos. It's really going to be helpful if we reduce this fraction. Okay, so I have 324 over 144, and it's actually better, hit that little fraction thing off to the side. It's actually better to think of this as 9/4 is equal to r squared. So now I can take the square root of 9, the square root of 4, and actually, what's our cheer? Square root, plus minus. So there's actually 2 formulas. R can be either plus or minus 3/2. So I can have a set of values that oscillates between positive and negative, or the one where it just always stays positive. So then our formula is g sub n would equal g sub 2, that's not a 2, to r to the n minus 2. And so this becomes g sub n is equal to 144 times, well, one of them is going to be a positive 3/2 to the n minus 2. How much do I want you to clean this up? well, we don't typically leave it as a -2 situation. So let's do this. Let's think of this as g sub n is equal to 144 times 3 over 2 to the n times 3 over 2 to the -2. And then let's come back to Desmos and clean this up a tiny bit. And what we're going to do is we're going to say 144 times 3 over 2. Right, oh, wrong spot for the parentheses. Raised to the, nope, not that. Raised to the -2. Okay, and so that equals, when I do that, that cleans up to be a 64. So my equation is going to be 64 times 3/2 to the n power. That would be a nice, clean version of that equation. Hopefully that's helpful. Let me see, what else do we need to do? The bell is about to ring. And actually, the other version, it's this, or it's g sub n is equal to 64 times -3/2 to the n. Okay, let's do the summary. I hope to go back and pick up the pieces, but I got to get ready for my next class. Geometric sequence is a sequence of the common ratio, and we can prove it by showing that g sub n over g sub n minus 1 is equal to r. If we take a term and we divide it by the term right before, the recursive formula g sub 1 equals g sub 1, and g sub n equals r times g sub n minus 1. The explicit formula is often g sub n equals g sub 1 times r to the n minus 1, or g sub n is equal to g sub k times r to the n minus k. All right, like, subscribe, comment, and go practice. Good luck to you.